Now we will solve some questions from the tutorial and some questions from previous exams. Okay, so this is question number 16 from your tutorial. It says that we have a rectangular sedimentation tank. This is to be designed for a flow of 20 million liters per day using 3:1 length to width ratio and overflow rate of 24. Okay, now the tank is to be 2.5 meter deep. Determine the dimension of the detention and the detention time of the tank. Okay, first of all, we want to measure the dimensions. So the area, dimension means area and depth. So area equals Q over V naught. Q is 20 million liter per day, which is 20 meter cubic per day, 20,000 meter cubic per day, over 24, which is the V naught overflow rate, equals 833 meter square. So the width to length ratio, if the width is x, so the length will be 3x because the ratio is 3:1. So the area equals x times 3x. So area is 3x squared. Okay, so the area 3x squared equals 833. So x equals 16.67 meter. Okay, so the width equals 16.67 meter. The length equals 3 times 16.67, and all equals 50 meter. Okay. And the volume is the area times depth. Area times the depth. So the volume is 2,083.33 meter cubic. Now let's check the HRT, hydraulic retention time. Hydraulic retention time, T equals 24 times V over Q. So hydraulic retention time is 2.5 hours. Okay, this is another example, or this is another question, and this is one previous exam problem. It was talking about the primary treatment. So here we have a sewage treatment plant is designed to treat wastewater from a population of 50,000 PE. Okay, it is given for you the PE, not the Q. So make sure you calculate the Q before you start. Then two circular clarifiers are aligned in series. Okay, in series. I put a line here because you have to know if it is in series or in parallel. It is different. Okay. Okay. And having a 3.5 meter side water depth. So 3.5 meter is the depth. Okay, side water depth is the depth. Single effluent weirs are located at the peripheries of the tank with a weir loading 200 at peak flow. This weir loading is calculated at peak flow. Okay, you have to notice all these things. Okay, based on the information given, determine diameter of each clarifier, hydraulic retention time at peak flow, and surface overflow rate. Okay, simply, we can calculate first the Q. We have PE is 50,000. So PE times the standard flow rate, or the average standard flow rate, which is 0.225, okay, meter cubic per capita per day. So the Q is 11,250 meter cubic per day. After we calculate the Q, we can calculate the peak flow factor, okay, PFF, 4.7 times 50, okay, over 0. Or minus 0.11. So the PFF is 3.06. And then the peak flow can be simply calculated is the Q times PF, okay, PFF. PFF is 3.06 or 3.1, it's okay. It's just a small difference, not a big problem. Okay, So here we have the peak flow, we have the Q, we have everything. Now, the weir loading at peak flow is 34385, okay, over the weir length. So we substitute in the equation using the peak flow because the weir loading 200 is given at the peak flow. So it's not correct if you substitute using Q, using normal Q. No, you have to calculate the peak flow, then apply to the equation. So you will calculate the weir length. So the weir length from this equation is, as you know, is 2 times pi times d. So this weir length is for two clarifiers. For the two clarifiers, both, because they are in series. We use the full Q, the whole Q without dividing, and the weir length will be multiplied by 2 because the wastewater is passing two clarifiers, the first clarifier, then the second one, okay? And because it's passing two clarifiers, so it is passing two weir lengths, two weirs. So that's why we have to multiply the peripheries or the weir length by 2, okay? 171.9, because we have the diameter, so simply we can calculate the weir length. Okay, sorry, from the weir length, we calculate the diameter. So this diameter is for one clarifier, okay? This diameter, of course, is for one clarifier, not for two. Why for one? Here, this is D, for one clarifier. We multiply by 2 because of the two clarifiers. So the D calculated here is for one clarifier. No need to divide it by 2 after that, okay? It's already for one clarifier. Okay, and then we calculate the area of the surface area. This surface area, of course, for two clarifiers, because we have, at the end, we have to calculate the hydraulic retention time. So we have the surface area by d square over 4, then it is multiplied by 2 because we are using two tanks in series, one after another, okay? Then hydraulic retention time is V over Q. V, is it volume for one clarifier or two clarifiers? It has to be for two clarifiers because, once again, the wastewater is passing from one clarifier to the second one, okay? In series, not in parallel. If in parallel, okay, we will use one volume for one clarifier for the hydraulic retention time, okay? And this is divided by the peak flow. So at peak flow is 2.9 hours. Okay, and the V node is 3.4. This is also peak flow over 176 and equals 29.2. Okay, and okay, so this is the question that we have solved. We solved the dimension, we solved the HRT, we solved the V node, weir loading and weir length and all the parameters. Okay, so this is simply was a question from our previous exam. I'll move to another question. Okay, previous exam, problem number 2, and also about primary treatment. We have two primary clarifiers. They are arranged in parallel, this time in parallel, not in series. Okay, and are designed to treat wastewater from a housing area of 10,500 PE. Notice that, again, it is giving to you the PE, not Q. Calculate first the peak flow rate in meter cubic per day of the area. Okay, so here, the average daily flow equals 0.225. So we have to convert this PE to a Q, okay, to meter cubic per day. So it is 2,362.5 meter cubic per day. PFF is calculated simply, as we can see, 3.629, and the peak flow rate can be calculated by multiplying ADF times PFF. Okay, this is in chapter 4, it's already taken in chapter 4. So the peak flow is 8,573.5. Okay, So it's calculated. Then the second requirement is the diameter of each clarifier. If the surface overflow rate at peak flow, okay, notice that it's given to you at peak flow is 45 meter cubic per meter square per day. Okay, so what do we have to do here? We apply the equation of Q. Q per clarifier, because they are in parallel, so each clarifier has its own Q. Okay, so each clarifier is have or receiving the half of the Q. Okay, so each clarifier Q is 4,286. Okay, so as you can see here, this is the peak flow. Okay, we are using the peak flow now. We're using the peak flow. Why? Because we want to check what? The peak area or the maximum area. Okay, the maximum area and the diameter of the clarifier. Okay, at peak flow. So V equals the volume equals Q over A. We have the Q for each clarifier over the area of each clarifier. So each clarifier will the overflow rate will be 45. So the 45 equals 4,286.8 over the area. So the area is 95.3 meter square. Okay, so 95.3 meter square is the area of each clarifier. So the diameter for each clarifier is 11 meters. 11 meters. Okay. Number 3, calculate the weir loading at peak flow. Notice that we are using peak flow only. We are not using the average flow. This is required by the question. Okay. So the weir length equals pi times d, and here we use pi times d, not 2. So we use only for one clarifier. Why? Because the wastewater is already divided from the beginning. It's already divided between two clarifiers. Okay, so they are not sharing the flow. So it's considered as separate lines, two separate lines, two parallel lines. Okay, so the weir length equals pi d. So pi times 11 equals 34.6 meter. The weir loading equals Q over weir length. So the weir loading can be calculated simply from the Q for each clarifier over the weir length for each clarifier. So it is 123.9 meter cubic per meter day. Okay, so this Q, as you can see, is taken for one tank only, okay, as the tanks are aligned in parallel, as we said just now. So the weir loading here is taken for one tank only. In the previous question, the weir loading was taken, or the Q in the weir loading was taken for both tanks. Why? Because the tanks were in series. Here the tanks are in parallel, so we take the weir loading for one tank. It's not something to memorize, it's something to understand, okay? It's because we already divided the Q, so we're moving in two separate lines. So the weir loading is not duplicated, Okay. Now this is question number 22 from the tutorial, and it is about the activated sludge system. An activated sludge system, if you read the question 22, it is giving to you the flow rate to 10,000, and the BOD of the raw wastewater is 1,200, quite high. And after treatment, the BOD is to be reduced to 50. Okay. The SRT, or the solid retention time, the sludge retention time, 5 days. MLSS, this is X, is 5,000. Okay. Y KD values are 0.7 and 0.3 per day respectively. So calculate volume of reactor, biomass wasted daily, and F over M ratio. Okay, let's see. So solution. First, we use this equation. It is in your lecture notes. 1 over TC equals qy times s naught minus s over vx, and all is minus kd. Okay, and notice here that the only unknown parameter is v. The only unknown parameter in this equation is v. The whole parameters are given in the question, so we can find v. We can find v. So simply just substitute in the equation and find v. V is found as, or calculated as 7,000 meter cubic. Okay. Then using this equation, Tc equals Vx over Qwxu. As I said before, Qwxu represents what? Represents the sludge wasted per day, the volume of sludge wasted per day. Okay, and V is the volume of aeration tank, and X is the concentration of biomass in the aeration tank. Okay, so the TC, we can calculate the volume of sludge wasted per day from this equation. We know V, we know X, and we know TC. So the mass of solids wasted per day can be calculated very easy. So it is 7,000 times 5 over 5, which is 7,000 kilogram per day. This is as a mass solids wasted per day. That's all for the question, question 22. Okay, so we move to another question, question 27 from your tutorial, and the question says an extended aeration STP receives 2,500 meter cubic of sewage daily, and the BOD concentration is 300. We have an FM ratio is 0.075. Okay, the MLSS concentration is 5,000. Its RT is designed for 30 days. Okay, now calculate the volume of reactor. Determine the volumetric loading, check the HRT, calculate the amount of sludge waste per day. So from this equation, F over M is given for us, the FM ratio is given for us, Q times S naught over V X. We can calculate the value of V. So we can know the volume of the reactor. So the volume equals 2,000. 2,000. Notice here that we substitute on x as substitute x as 0.3, not 300, okay? And x is 5, not 5,000, okay? So just make sure you substitute correctly, okay? So V is 2,000. And then the volumetric loading is Q naught times S naught over V. We know all these parameters, all are known, so we can simply calculate the VL. Okay, is 2,500. Q naught times S naught is the 300, which is 0.3, and then the volume is 2,000. So the volumetric loading is 0.375 kilogram BOD per meter cubic. Okay. And then, of course, this volumetric loading is within the accepted range, because the range for the extended aeration for the VL is from 0.16 to 0.4. So this one is okay. Okay, so you have to mention if it is asked, or if the question asks you to check whether it is suitable or not, whether it is okay or not, you have to mention and you have to justify your decision. A sentence like this or simply writing something like this is enough for the answer. Okay. Okay, now move to the HRT. HRT equals V over Q times 24, calculating by hours. So the HRT is 19.2 hours, and this is also okay because it is within the range from 18 to 24 for the extended aeration system. Okay, now we calculate the mass of sludge wasted per day, which is Vx over Tc. This is Qwxu. Okay, and the Tc is 30 days, X is 5,000, which is substituted as 5, and then 2,000 for the V, which is 333 kilogram per day. Okay, and this is the end, or this is the end of the question. That's it. Okay, now we move to a previous exam problem. Okay, as you can see here, this problem is talking about activated sludge system. Just a minute. Okay, so an activated sludge system is designed to treat wastewater from population of 10,000. Again, it's given for you the PE, not the Q. So the influent BOD is 210 milligram per liter. Okay, this is a complete mix reactor. A complete mix reactor is to be used from a pilot plant study. The Y and KD are known. Assume MLSS concentration of 3,000. Okay. Mean cell residence time 10 days. Underflow concentration from secondary clarifier is 9,300 milligram per liter. So the effluent of the treatment system should comply with standard A. Comply with standard A. So you have to know what standard A requires as for the BOD final. Okay, this gives you an indication that you have to know the BOD final by checking the standard A requirements. Okay, so here determine the dimensions of aeration tank. Provide two rectangular tanks arranged in parallel. Use width to width ratio 1:2, and water depth of 4 meters. Okay, so it is giving to you something. You don't have to assume. If you assume something different, it will be wrong. Okay, it will be wrong. So the water depth is 4 meters. Width to length ratio is 1:2. So this is a rectangular aeration, rectangular tank. Okay. Okay. Now the food to microorganism ratio, you have to calculate the recycle ratio. Okay, the R, and you have to show mass balance. If you didn't show mass balance, you will lose marks. Okay, because everything is marked with a certain or with a specific amount of marks. Okay, now the overall plant, also the overall plant efficiency, which means how much BOD is removed in terms of percentage, how much percentage of BOD is removed. Okay, this is the solution. Volume of reactor, the V is V equals Q times T, but how much is the T? We don't know the T. So we have to know how much is the T. First, Q equals 10,000 times 0.225. Okay. Standard A means that the S final will be 20 milligram per liter. Okay. If you check standard A requirement, S or the BOD final should be 20 milligram per liter. Now, 1 over Tc, this equation is given in the lecture notes. 1 over Tc equals Y times S naught minus S over Tx minus Kd. So if you substitute in this equation, you can find what? You can find T. You can find T. So 1 over 10, after we substitute, you just find or solve for T. So T equals 0.211 days. 211 days. Okay, so V equals QT. Then we can know the volume by multiplying Q times T. So Q is 10,000 times 0.225. So it's already calculated, and the V can be calculated after that. So the V is around 475 meter cubic. Okay. So for each tank, it has to be divided by 2 because we are using 2 tanks, right? Okay. So the area for each tank is dividing the volume by the depth, so we can know the surface area for each tank. Okay, and then the width to the length ratio, so 1:2. Okay, so the width equals to W square. And this equals 59 something. So the width is 5.45 and the length is 10.9. 10.9. Okay, same as we did in the previous examples. Okay, now we calculate the FM ratio. FM ratio simply from Q is naught over Vx. So Q is naught over V times X. Make sure you substitute correctly and equals 0.33 kilogram BOD for each kilogram mixed liquor suspended solids day. Okay, recycling ratio is QR over Q, but how much is the QR? We know the Q, but how much is QR? If you go to the lecture notes, I don't know which slide, but it is mentioned. If you see the slide that talk about the mass balance around the final clarifier, okay, you can see that there is an equation for QR, and this equation is derived from the previous equations from other equations. So it's not something new. It's derived from other equations. Okay, if you make mass balance around the final clarifier, you can know the value of QR. So QR equals QX minus QWXU over XU minus X. So you can know this QWXU first. You have to calculate QWXU in order to calculate QR, in order to calculate the recycle ratio. So first, QWXU equals V times X, which is 475 times 3 over 10, okay, over TC, which is 10, equals 142.5 kilogram per day, okay. Then we go to the equation of QR again, this one, okay, we substitute here. So QR equals 2000, QR equals 1048.81 meter cubic per day, okay. And then we can calculate the R, which is QR over Q. So the recycle ratio is 0.4661. So that means around 46 or 47% of the sludge will be recycled. Okay, it's almost the half of the sludge is recycled to maintain what? To maintain the food to microorganism ratio. Okay, this is something related to the aeration tank and to maintain the reaction inside the aeration tank. Okay. And finally, we can calculate the efficiency. So the efficiency is BOD initial minus BOD final over BOD initial times 100. So it is 90.47%. So the efficiency is around 90 to 91%. Okay. So here I finish my questions. So if any of you have any question, whether it's practical or theoretical question, please put it in the chat or send it to the WhatsApp or maybe to the email or whatever you